So yesterday, the absolute value function was introduced, and the absolute value function does not have slope. And so we are using transformations to graph that. We talked about the domain and range of absolute value functions and graphing those. So let's review if I have an absolute value function. So if I'm looking at the exploration handout, I know that if I have a number multiplying my x, that it's going to vertically stretch or shrink it. So if you think about lines, if the number was bigger than 1, it made it steeper or taller. So the same thing here for absolute value. If the number is bigger than 1, it's going to vertically stretch it, making it taller and skinnier. If the number is less than 1, like 1/2, it's going to vertically shrink it. And think about if your slope was less than 1/2, it was flatter. For absolute value, it's going to make it wider. Okay, now, also remember a pattern that we said, that if a number is added or subtracted inside the function with the x, it's going to, since it's with the x, it changes the x. However, it's the opposite. If I have x minus h, it's going to move right h. If I have x plus h, it's going to move left h. Now, not a surprise that if we have a number away from the x, it's going to move it up or move it down, and we saw that when we had y-intercepts with lines. So if it was plus k, it's going to move up k, and if it was negative k, it's going to move down k, just like what we think. And then, of course, a negative on the outside means that it is going to reflect it. Okay, so I'd like you to stop the video, and I would like you to do the matching on the next exercises, exercise 1. So I would like you to look for the vertex, and so look for the transformation, which is going to change the vertex, and then find the matching graph. So if you are back, you completed the matching. So 1A, how did it change from the parent graph? It was reflected and moved right 2, so that means it was graph D. In part B, it was moved right 2 and up 2, so the vertex changed to 2, 2, so that's why it's graph C. In the next one, it was reflected and moved left 2 and down 2, so the vertex is negative 2, negative 2, that's graph E. In D, it was moved right 2 and down 2, so the vertex is 2, negative 2, so it's graph F. And in E, it was moved right 2, so the vertex is 2, 0, but it was taller and skinnier. It was a vertical stretch by 2, that's why it's graph A. And then in F, it was reflected and it was moved left 2, up 2, so the vertex was negative 2, 2, but reflected, so upside down, graph B. Okay, so now on your own, I want you to turn the page, and I would like you to, in number 2, list the changes. Write out how this is going to change from the parent graph. So if you need to stop the video, and write out those changes. See what you can do from memory. Because graphing these by transformations is a lot easier than trying to make an XY chart and put in a bunch of values every time. It's just like when we started with lines. We did that at first, but then once we found slope and y-intercept, it made it so much easier. Okay, so now let's take a look at number 3. I'm asking you to go backwards and write the equation of the absolute value function. So the first thing I always encourage you to do is to find the vertex. So the vertex is negative 1, 1, which means it moved left 1, up 1. So what I would have done first is, if I knew it moved left 1, then that's a plus 1 inside my absolute value. And then if it moved up 1, that means there's a plus 1 hanging on the outside of this. Now the fact that it's reflected means I put a negative on the outside. Okay, I'm going to do a couple of the next page, a couple problems. You're going to do 2 and 3 on your own. But I want to take a look here to show you, just with an XY chart, or how the graph really does change. So if you take a look at number 1, I gave you these domain values. So if we put in negative 4, absolute value of negative 4 is 4, half of 4 is 2. Absolute value of negative 2 is 2, half of 2 is 1. Absolute value of 0 is 0, half of 0 is 0. Absolute value of 2 is 2, half of 2 is 1. Absolute value of 4 is 4, half of 4 is 2. Because remember, absolute value always makes numbers positive. Okay, so now if you go to graph this, you can see that this is flatter. So if you need to stop it to graph it, Go ahead and graph it. My vertex is still 0, 0, but if I compare this to the parent graph, this is a lot shorter and flatter. It's vertically shrunk by a half. All right, now what's the domain? Well, hopefully you've caught on. If I made an XY chart, I could put in anything I want to absolute value. So that's why the domain of an absolute value is always all real numbers. If you don't want to use that notation, write all real numbers, that's fine. Now my range, I have to look at my y's, but I can also use my graph. My graph doesn't go to the negative part of the y's. All right, so I don't have any negative numbers. I have positive and I have 0, so y is greater than or equal to 0. Okay, I would like you to do 2 and 3 on your own. I'd like to go to number 4. So number 4, I gave you some domain values to plug in. So the absolute value of negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. All right, negative 3 plus 2 is the absolute value of negative 1, which is 1. Negative 2 plus 2 is 0. Absolute value of 0 is 0. Negative 1 plus 2 is 1. Negative 1 plus 2 is 1. Absolute value of 1 is 1. And 0 plus 2 is 2. Absolute value of 0 is plus 2 is 2. Okay. So these are the values I got out. So if you need to stop to graph these, I got negative 4, 2, negative 3, 1, negative 2, 0, negative 1, 1, and 0, 2. So if you weren't quite sure why this would translate at left 2, once you go to graph this, do you see that now my new vertex is at negative 2, 0? So I just did these questions just to re-emphasize to you why or how these changes work, and why I knew this would be translated left 2. So domain and range. Domain, of course, I could have put in anything I want, so it's all reals, and you can use the notation or all reals. Now my range, some people get confused and they're going to say negative 2 to infinity. Range are your y values. Did this move up or down? It did not, so the range is all positive numbers and 0. Okay, so you may want to turn over that page. I want you to do some extra problems here. I am giving you a graph, and I want you to name the domain and range. So if you need to stop to graph this. So this would be like a quiz question. I give you the graph, you name the domain and range. Okay, so again, my domain for any absolute value function, if I made an XY chart, would be anything I want. So all reals. If you want to put negative infinity to infinity, that's fine, or all reals. Now my range, okay, my range, I did move my vertex over to 3, 0, but I did not move up or down. So unless I move up or down, my range is going to be everything bigger than or equal to 0, all positives and 0. Okay, let's take a look at number 2. If I gave you this graph, name the domain and range. So of course the domain, if I had made an XY chart and said find values for this graph, you could have put anything you wanted in for the domain, which so all reals. Now this graph is moved down right 3 and down 2, and it's reflected. So the range, look at my y values. There's nothing above negative 2. So that's why my range is y is less than or equal to negative 2. Okay, now if I give you this next equation, I want you to graph it. So I'm asking you to graph the absolute value, f of x equals 2 times the absolute value of x plus 1 plus 2. Okay, anytime you're graphing absolute value, you need to find the vertex. So to find the vertex, what change happened here? It moved left 1 and up 2. So my vertex is at negative 1, 2. So I would have that. I need to know that for sure. Left 1 up 2 means my vertex is negative 1, 2. So there's a point. Now what else is going on? This vertically stretched by 2. So since my vertex is negative 1, 2, I may make an XY chart to find some other values. If negative 1 is my vertex x-coordinate, I might plug in numbers around it. So I'm going to put in an easy number like 0. If I put in 0, 0 plus 1 is 1. Absolute value of 1 is 1. 2 times 1 is 2, plus 2 is 4. Now, this has symmetry. So if 0 was equal to 4, then negative 2 will also have a 4. And that's how to show it's vertically stretched. So more practice. You need to know absolute value function, what it looks like. We need to be able to find the vertex. Graphing them using transformations is the best way. We also need to know how to name domain and range, and we need to know how to go backwards, how to write the equation given the graph.